Kelly O'Brien. I'm an assistant professor at the University of Dallas and the coordinator of this year's Fab Lab. This is the third year of a 3-year project. And I'd like to thank Brackers Clay for their support, as well as Scott, and most notably West Virginia University. The Fab Lab project is a collaborative project between West Virginia University and NCECA. Check out the exhibition outside. There are some sort of works in progress and finished works from the presenter collaborations that have happened as a result of this year's Fab Lab. So it's just outside in the atrium. And I'd like to introduce Marty Fielding and Eric Adams. Marty Fielding divides his time at Florida State University between teaching ceramics and managing the facility for arts research. He earned an MFA at the University of Florida, where he began incorporating digital fabricated elements in his work. His work has been included in many solo and group exhibitions nationally and internationally, and is published in several books and periodicals. And I know Marty from North Carolina. The first time I ever bought a mug out of a trunk, it was out of Marty's trunk when I was an undergrad, out of his car. I was like, oh, this is wonderful. And I still have it, in fact. And Eric Adams is an artist and educator that lives in Tallahassee, Florida. He is currently the ceramics lab manager and an adjunct instructor at Florida State University. He earned his MFA from the University of South Carolina in 2016 and a BFA from Jacksonville University. He was a visiting artist in Jacksonville University and has also received scholarships to Penland School of Crafts and has participated in exhibitions throughout the Southeast, including Georgia, Florida, Kentucky, North Carolina, and South Carolina. And today, Marty and Adam will present to you their most recent research on material and artistic exploration related to this very large, unique printer that they have access to. And with that, I'm going to turn it over to them. Thanks.
Hey, everybody. Thanks for coming. As Kelly said, we're both at Florida State, and we both started relatively recently. I started in August of this year working in the Facility for Arts Research, which I'll get a little more into in a minute. But one of the pieces of equipment that is there and has been there for a little while is this printer that's called the MMAP, so the Multimodal Additive Printer. And having the invitation to come and present here sort of spurred and kind of fast-tracked some motivation to kind of spend some time working on this machine and trying to kind of revamp the clay possibilities with it. So just a couple things, we kind of wanted to introduce ourselves a little bit. I've been working with clay for quite a while. I make vessels, and my interest in digital work has been largely sort of making trays and platforms for the pots. I'm interested in architecture, painting, and music, and sort of looking at groupings of pots as skyline and musical progression. And I feel like, with this image, this kind of shows interior. It's kind of an allusion to interior structure of architecture, which is something that we'll kind of get more into when we'll look at the MMAP as well. It's kind of something that is interesting me about using this machine for my work. So I've done a lot with CNC mills and laser cutters largely. So the printing with clay is a newish avenue for me. And I'll pass this over to Eric.
Hey everybody, I'm Eric. I'm kind of a new digital person. I've started in ceramics, making pots and things, and I really became interested in sculpture. And I've always loved using computers and working with technology, but it's always been more of a practical concern for me instead of I never really used it in the studio. This is an example of some of my more recent work. In graduate school, I started working on a series of works about sugar and how sugar is this weird material in our daily diet, but it's so processed and so industrial, and there's this relationship between sugar and this industrial world that I can't really understand and rectify. So I was making a lot of work around that, And I started at Florida State in January of 2017. Advance that one on. And it really kind of sparked my interest in using these tools in the classroom and in my own work. So that was kind of my impetus for starting this project. Yeah, so that's a little bit about me. Yeah, and so at Florida State, I think we have a really strong program that uses technology. I teach a class every summer called Digital Foundations it's mostly for sophomore and freshmen that we go over the basics of basically every digital program students would be using. So the Adobe suites, some 3D modeling, SketchUp, and having to use those tools in this class really gives these students groundwork to be able to use these tools and these resources in every course. So having that foundation when I'm teaching a beginning ceramics course or a slip casting class, I can have students just run up to the Fab Lab, print something, cut something. So that's really how I've started to get interested in this, and why a lot of my work is kind of going into those things is I want students to be able to use those things to augment their practice, not necessarily become their whole practice. So at Florida State Ceramics, we have a smaller Delta printer, so like we have here, and there's also the larger MMAP that I think Marty can kind of start talking about now at the Facility for Art Research.
Yeah, so Florida State, the art department has this kind of unique building that's dedicated to faculty research, and there are several faculty, sort of ongoing faculty projects that are happening there. A few things are the Small Craft Advisory Press, which is a printmaking and bookmaking space. There's the Comma Project, which is kind of, the idea is a collaborative exhibition that comes wrapped up in a little box, so which is kind of a fun idea. And then there's also the Reboot Laboratory, which is dedicated to kind of reusing materials that would otherwise would be trash. The other thing that has been happening at FAR for a while, FAR, short for Facility for Arts Research.
We have a lot of acronyms at FSU.
Yes, lots. There's some digital equipment there as well. So we have a laser cutter, a CNC router, several 3D printers, and then this one again, which is the MMAP. And this was designed and built by a guy named Wyndham Graves, who was a graduate student at Florida State. He received a pretty large grant from the Florida State Research Foundation to purchase this. It's built on a 6x8 foot ShopBot router. And his idea was to make this sort of large scale printer that could be used to print with multiple materials, with sort of minimal time to change from one print head to another. So some of the things that it's been used for were printing plastic. So it uses this Demtech plastic welder as the hot end, and uses this 10 millimeter HDPE and ABS to print with plastic. And these are a couple of pieces of Wyndham's. It's been called the toothpaste printer because, I guess just the width of the extrusion. It's also been said that you could print Mini Cooper on this thing, or something the size of a Mini Cooper. This machine has also been used as a 5-axis indexer, and in a collaboration with Anthropology, this Olmec head was made, and this thing is, I think, like 3 by 4 feet wide. So a router was attached and used like a lathe. And then in the past, there've been a couple different print heads used for printing with clay and also concrete. There was what was this thing called? A quick point lightning grouter that was used for printing concrete, and then this power caulker. So this was sort of retrofitted to fit on the machine to use for printing with clay. So basically, this thing holds a caulking tube full of clay, and mechanically there's a plunger that pushes the clay through. And we'll talk a little bit more about that. That was sort of our first step in this project, was kind of reconnecting this caulker and getting a feel for how that would work. Some of the things, or probably the largest body of work that's been made on this machine, was by Michael Rees in 2013 and 2014. And these are a couple pieces that he made there in a fellowship at FAR using the MMAT printer. There were some electronics involved here, and photographs, and sort of mixed media. And then Eric's going to talk a little bit about our collaboration.
Yeah, so we collaborated on this project throughout the entirety, starting really with a printer that didn't really work that well. We started using the power cocker kind of at the beginning of this project, and did not like the results at all. It was very clunky, not a very accurate print, not a very good print. And I think a lot of Marty and I's positions are constantly collaborating because we're both interested in technology, we both work with ceramic, and we both teach it. So we have a lot of collaboration in and outside of the studio for all those kind of things. But to start, I think a lot of people, when they collaborate on projects like this, they might start thinking about artwork, or what they're going to make, or how they can represent their two bodies of work. But for our project, we really had to start with how can we work together to make this machine print better? How can we break this kind of large task of completely redesigning this print head into something manageable, that using the kind of resources we have and the time we have? So that was really the start of our project and our collaboration, not so much drawing or sketches of artworks or pieces we wanted to make, but how can we print better? So looking at other designs and how to rework them onto our machine. For myself personally, I'm really interested in how far I can take this machine. I first started 3D printing with plastic in January of 2017 when I first got to FSU. And I was amazed with the quality of prints I could get from remixing and moving things between a physical realm and a digital realm, being able to scan an object, 3D print it, and then slip cast it, or cut it apart, rescan it, just being able to work in and out of that. So I'm really interested in how far I can push this technology into something that I really can't understand and don't really have a roadmap to use. And for that, it doesn't really lead to a lot of what I'm going to make or what objects I'm going to make. It's more about thinking about the process or the system, and also how to make it usable for other people. I feel like I'm fairly technically minded and really enjoy, sometimes masochistically, taking on these projects of almost beating your head into a wall every day when you hit a roadblock. Yeah. And then aesthetically, I think Marty and I have some similar goals in what we're interested in and what kind of drives our work. But if you wanted to talk a little about what you might be interested in the collaboration.
So yeah, I think, like Eric said, the first thing was this, the kind of technical aspects of making the machine work, and then I think one of the things that we were drawn to about some of what we've seen from the machine previously was this idea of the infill of the print. So for I'm sure many of you know, but when you're printing with 3D and you have, or when you're 3D printing and there's a top to the piece, there's got to be support on the inside that's gonna hold that, be able to support the top. And so I was really drawn to just this internal structure again, and the possibilities with that. So that was one of the things that we sort of found in common as an aesthetic goal or something to work with. And I think sort of the third part of this collaboration was, we design things to print, and then we give it to the machine, and then the machine makes it, and of course it's nothing like, the machine has its own touch, of course, as all do. And I think something that was sort of clear about this one in particular is it's a larger extrusion, which we'll kind of get to later. So the detail, or it's much lower resolution than people are used to with a plastic printer. So so the detail was kind of minimized, or at least at the scale we were working. So there's this third voice in it that we had to kind of figure out how to work with.
No, definitely.
And so we want to talk a little bit about the process of getting it working and kind of the parts that we made to print with clay.
Yeah. So one of the first steps was throwing out that power cocker. Thing just did not work very well. As Marty mentioned earlier, it was really using a ShopBot motor that's controlled by the ShopBot software to drive a plunger down, much like hooking up a motor to an extruder. This system had drawbacks because a lot of the parts were made out of plastic, and when you're putting that much force on clay, it slips and pushes back and doesn't work. So I had seen a lot of different designs, and some of you might have seen them here, for auger extruder heads. The most notable I can think of are the Wasp system. Jonathan Keep has a very similar design, Tom Lauerman. So I was looking at a lot of these designs. Yeah, Brian. How to adapt this design to this much larger motor and this much larger printer we're using. So I 3D model a lot of things in Tinkercad, which is a very simple software. I'll talk about that in a little bit. But this is just an example of the actual model I built, starting from a really, really loose iteration. Like this is kind of a more finished product, but I probably made 25 to 30 different ones to get to that point. And here are all the separate components of it. So this little, on the very right-hand side, that tube over there, that is where our clay is being fed in. And we're going to talk in a moment about the different ways we tried to feed the clay into that. And once the clay is going into that, there's a small lag screw in, not very small, but a lag screw that's inside that chamber that's driving the clay down, very similar to a pug mill. If any of you have ever used a pug mill, it's a really large auger in there, and as clay is pushed through, when it turns on the motor, it's going to drive clay forward or backwards. So in our case, having a 3D printer really opens up the ability to be able to model that and use so many already manufactured parts. Like we didn't have to reinvent the wheel so much as just redesign the plastic components and scale everything up. And after getting most of that working, we then kind of had to switch over to thinking about our extrusion systems and how to actually get clay into that auger head. Because at this point, no clay is coming out of that yet. It's just, there's no clay coming into the actual auger.
So we were trying to decide what kind of system to supply the clay with. And you know, we did a lot of, I mean, it's great that there is this DIY community that's putting out a lot of information about this type of printing. And so we were looking at a couple of different possibilities. One was using a mechanical drive, and then the other would be compressed air. And so one of the things that we found also, you know, sort of in connection with this machine was there was a spare Z-axis component for the ShopBot. So what that could give us was one, a motor and a gearing that could possibly push the clay through a piston. And so this was an early drawing of kind of the plans for making this mechanical system using the ShopBot equipment that was there. So we built this, and this is the final product. And once this was built, we found that it was really difficult for the motor that we had to drive the clay. Well, it was really easy to drive the clay through the pipe, but as the pipe got smaller and smaller and was going to go into a tube to feed into the print head, it was impossible for this thing to work at least with the motor that we have.
Yeah.
So
if any of you saw the PotterBot, we're kind of trying to replicate something like that, just using a larger motor. But the issue is that we were hoping to connect that to a tube that would lead to our clay so that we could have it kind of far away. And as soon as the compressed clay hits that tube, there's just not enough force. You would need a motor probably the size of this table to drive it through a 3-foot tube, which can't really move around that easily.
So it did work, It worked. I have proof that the mechanical part of it
The
worked,
concept worked.
but it just wouldn't push the clay, with enough volume and with enough speed to actually print. So we switched to, or we moved to the compressed air possibility, and so this was really modeled quite a bit from Brian Zebez's clay canister that he's recently put out for us to borrow. So similarly, throughout this there was CNC milling parts for this, and so the end caps of this machine were milled at FAR, and we're lucky to have compressed air kind of running throughout the building. So that was a simple thing to add. So this one is slightly larger than Brian's. The thing about the machine that's I think the most unique is the size, right? So we're interested in trying to push towards that potential of size. So having the largest amount of clay supply possible, and I think that's kind of a work in progress.
Right now, we're using just standard plastic clay that's just very, very wet, and that can hold about 25 to 20 pounds of clay at a time, so we can print fairly large volume right now. We're hoping to really expand that as far as we can. I think if we can find a system that can extrude the clay, we could print couches, really, really large things, whatever, a Mini Cooper, whatever we wanted to. Yeah.
They'd be nice and comfy when they're wet.
Yeah.
When they're soft.
Yeah. Kind of mold to you when sitting.
Yeah, but so this is the current version of what we're working with. So this is a 4-inch PVC tube that's 2 feet long, that is holding the clay, and then that's feeding into the print head.
So I'd like to talk for a moment just about our workflow, because I think a lot of this can be fairly technical and jargony. So when working with software and any kind of 3D printing, you have 2 different kind of processes you're using. You're using a CAD process and a CAM process. So the CAD is just your computer-aided design. That is actually preparing a model. So you have to draw, make, sculpt some kind of object to actually be able to print. The 3D printer, the CNC, has to be able to read some kind of a file, which are typically STL or stereolithography files. So Marty and I both work with very different flavors of software. So for most of my 3D modeling, I was using Tinkercad. That's, again, a very simple program. It's actually made for teaching children 3D modeling, but I really like that simplicity and that I don't have to be bogged down with so many tools. There's other software I sometimes use if I need more complicated process or other thing, but most of the things I make, Tinkercad can really do it, or some combination of it. Where Marty's using Rhino a lot, and I think Rhino or Rhinoceros is a more well-known 3D modeling program for the ceramics community, and has a lot of features that are really, really great. And I kind of really enjoyed that we were almost never working in the same software, and the freedom of just being able to kick in and out of each program and convert is kind of fun to me. So once we have a 3D model prepared, right, we draw our object, we draw our cup, whatever we want to make, we then have to have a CAM software, computer-aided manufacturing. So if you're working with a subtractive tool like a CNC router, that would be called a tool path. That's just what's cutting everything out. It's telling the machine where to go. And in our case, for additive manufacturing or 3D printing, you're taking whatever your model is and you're slicing it into layer heights that you decide. So for us, our layer height is just whatever the size of our nozzle is, which is why we have kind of thicker striations than you'd see on some plastic 3D printed stuff. So for us, we're using Slicer, which all of the programs are called Slicer. So this specific one is also called Slicer. A little bit of confusion there, but it's a fairly well-known slicing program for 3D printers. It's used a lot for plastic, and it's mostly designed for plastic. So there's some issues we ran into using that, of having to convert to telling the software we're not using plastic. The material's not going to behave like plastic. It's clay. But that's what's actually preparing our model that we can then load into the ShopBot and print. One other note on the CAM side of this that's not on here is that ShopBot uses its own language of G-code. G-code are just the commands that are created by the CAM software that's just plotting and telling the machine where to go. So Slicer puts things into a certain type of G-code, and then we have to convert that into another one afterward. No worries.
One more. Just to the right.
Got a good smile. So yeah, once we have that file processed, we just have to convert it using the ShopBot software, which is totally proprietary to just that machine. You don't use ShopBot language for anything but their tools. So that's just a little of how we're actually printing with this machine.
So bringing up the software, it makes me think, you know, this, who 3D prints? Who's here? Who's scared of 3D printing? Who has built a 3D printer?
Nice.
I've used some of these tools, but it's always been that. It's been using the tool. And I feel like before this project, the idea of building one of these tools was, you know, just totally intimidating to me. But I feel like, I guess for those of you who aren't raising your hands to answer these questions, you know, I feel like it's not as difficult as we might think before we get into it. That's not to say that there aren't challenges along the way, but I think kind of figuring out the mechanical aspects is definitely possible. So there are lots of bumps along the way. Just things like obviously with the clay supply system, you know, we had these grandiose plans that this mechanical part was going to work, and it didn't. So we changed direction. You know, Eric's talking about the software, and we have to convert from one type of code to another to work with this machine, and there's issues with that as well. But nonetheless, you know, through all this, I feel like, you know, I feel like much more comfortable. Like I'm ready to build my own machine now, I feel. So I think kind of when you peel back the layers a little bit and get into the thick of it, you know, the possibilities, at least in my perspective, seem, you know, not so scary anymore. But again, this is the machine as it is now. And then we have some images of work in progress, and also some videos of it printing, all of which are sped up, so it's, you know, it's really fast progress.
Yeah. So yeah, we tried a lot of these different systems, and we finally settled and got Air to work. So, you know, we talked about the tool head and a little bit how it works. So now, if you see on the right corner here, that is our air canister, and we're using about 80 to 100 psi, pounds per square inch pressure, to push that clay through that little tube into the print head. Once it's in the print head, the auger is then controlling kind of the rate of speed for how it's printing out. And one of the things that I find to be very troublesome and kind of cumbersome, especially for people who aren't just really jazzed about this stuff, is actually loading the tube of clay. So there's two of those plastic end caps are held together by all of those threaded rods, and all of those have to be removed, and then we have to use an extremely wet, I'd say it's like peanut butter consistency clay, just really be very difficult to throw or hand build with. And loading that up into the machine very slowly using a scraper. If you have watched any of Brian Zebez's or Jonathan Keep's videos, you can kind of see that process. So it's kind of difficult, and I think that can be very intimidating for people who just really aren't excited about this and can push people away. So one of the challenges going forward will be ways to streamline or make that process more efficient and easier, so that using this doesn't have to seem so daunting.
So some of the work that we have made, a couple of these pieces are out in the show. But so again, some things that we were interested in terms of the collaborative work. One again was looking at this internal structure, also kind of largely showing the material as it is, like not a lot of glaze.
No.
We used a lot of terra sigillata for the surface and a couple of glazes. And also, the mark of the machine obviously is a part of it.
Yeah, I think that was one of the most challenging things to deal with. Having done a lot of plastic printing before this, I got very used to what I saw on the computer screen is what existed in the world fairly accurately. Not a whole lot of change between the digital model and the actual object that would come off of it. We're printing with clay, I'm preparing these very geometric and very tight models, and the machine, they never ended up looking like that. There was always this character, this hand of the machine, how it's printing, moving in and out, that didn't bother me, but it was an adjustment to deal with, and how we would, how to use that information and be working. Because being trained in ceramics, I'm used to just seeing what's in front of me and responding to that. Where here, I'm looking at a computer screen and having to respond to what's in front of me there, and then changing that to the actual object that's in front of me afterward. So it was kind of a complicated process of doing that, switching in and out of this digital and physical realm all the time. I think that made it kind of challenging to know what I was actually going to see from the digital model to the actual object. So,
And the way that we were sort of working together in terms of the artwork was kind of designing parts or designing forms individually, passing them on to the other person who would then respond to kind of make these pairings of pieces that would go together. So these are a few examples of those. And then, as we've been working with this since I think maybe December. So it's a few months of progress, a little bit of step forward, step back, and ultimately moving forward. But we're definitely not at an end point with this thing at this point. And also, it seems to me, looking around the clay printing community, that does anybody ever find an end point? It seems like it's kind of it's an ongoing development for everybody that's working on these machines. So I think one thing about this machine is, again, the scale, and so we haven't really realized the potential of the scale or using the scale yet. So that's something to continue working on. In terms of that, we're trying to have a large amount of clay that's kind of at the ready to be printed without stopping. Another thing that we were using was about a 5.5 millimeter extrusion size. So it's a relatively large width extrusion. I think it would be interesting to take that up more. Like if we could have a larger amount of clay to work with, and increase the scale of the extrusion, et cetera, and just the ability to print larger pieces. Another thing that Eric is probably especially interested in.
Yeah. So I wouldn't even say decreasing the scale as much as just being able to print a higher resolution, being able to make clay print similar to an FDM or a plastic printer. Not only just to see where we could take that possibility. Like if I can design an object and print it in clay and have it look very similar, I think that opens up a lot more doors for augmenting people's practices, not really replacing it with this technology. Because that's a fear and I think a liability I hear from a lot of people of how do I use this if I'm interested in working with my hands? And I think the best way I've heard it put that I didn't come up with is thinking of it like a prosthetic. It's just a way to enhance and to be able to do more than what we have. So I'm really interested in hopefully being able, a lot of the resolution issues are a combination of the filament size or the nozzle size and just software limitations of using a CNC router. It's not really designed to move additively. It's meant for subtracting. So all of the software, all of the programming is designed that way, which we run into a lot of limitations with that, trying to use it for not that purpose. And neither of us are engineers or software designers, so creates some problems sometimes.
I think it would also be, I'm interested in kind of revisiting this mechanical clay delivery possibilities as well, possibly with a different motor or another way to approach that part of the equation.
Yeah. And I feel like we're really just scratching the surface of the potential of this machine and all of the things it might be able to do that we haven't even thought or realized yet, because we're still working on these very, very small, just tedious issues of functionality. And I think once we can kind of break through some of those, there's a lot more potential for exploration and doing a lot of different things with the machine, printing in different axes, maybe adding on different kinds of heads. That's a problem I have with this process is I just keep thinking of ideas of things I want to make, but they're not artworks or objects. They're just these processes and these machines. And it's hard to reconcile that sometimes, but it's kind of fun too.
And and I think in terms of the DIY community around this, it is proof in a way that, or this could be applied to other ShopBot machines potentially. You pull if your school has that, or if you have that, you could potentially take the router off and use the machine as a printer as well. We're not really in a place to publish kind of finished designs, so to speak, at this point. But this could be another avenue. I think a lot of the DIY thing is great because it is putting out inexpensive ways of making printers. This one's definitely not that. But I think if you already have the machine, it could be something that could be adapted. And does anyone have any questions about anything? Excellent. We answered all the questions. Well, here are some web addresses, et cetera, email addresses. If anybody has any questions in the future, feel free to get in touch with us. Yeah. There's FSU Ceramics here. If you want to find out more about FAR, you can see more about the projects that are happening there. And of course, you can spam us personally if you would like to.
Yeah, absolutely.
With anything. Thanks for coming. Thanks for listening.
Yeah. Thank you, everybody.
Yes.